So welcome to the 8th and final video in the first special relativity topic. In this video we will be looking at the space-time interval. So over the last 3 to 4 videos we've learned about, and are very probably still trying to come to terms with, some phenomena that are completely outside our everyday experience. And 2 of those are time dilation and length contraction, or in other words, the phenomena that neither time nor length are constants. And that leaves us with the question if there is anything at all that remains constant as we travel at relativistic speeds. And the answer to that is that actually yes there is, and it is something called the space-time interval. And to describe what that is, I'm going to take us back to our space-time diagrams. So what we have here is, once again, we have our blue reference frame. So this is the reference frame from the man's point of view, and we're calling this at the minute our stationary reference frame. And then we had our red reference frame, which is the reference frame from the point of view of the rocket. So measuring between any point inside that red reference frame gives us the point of view of someone on the rocket. Measuring that red reference frame relative to our blue reference frame gives us what it looks like is happening inside the rocket to someone standing stationary, or to someone in that blue reference frame. And we have 2 points on our blue reference frame and on our red reference frame. So in the x direction they represent a distance of 1 light meter, and in the y direction they represent a distance of 3 times 10 to the 8 meters, or 1 ct meter. And so if we look at that distance, how we write that distance, the horizontal distance in the blue reference frame, we write that as the length, which is equal to delta x, which is x2 minus x1. And similarly, in the red reference frame, we write the same. We write L dash is equal to delta x dash. And we know how to transform between L and L dash, and we know that L is not equal to L dash. And looking in the time direction, so on the CT axis in the blue frame, we find that that difference, delta CT, which is, since C is a constant, that's equal to C times delta T, is equal to C times T2 minus C times T1. And likewise in the red reference frame. And once again, we know how to transform between the times T2 and T1 and T2 dash and T1 dash, and we know that they're not equal. And now what we do is we define the space-time interval. And our space-time interval is defined as the separation in time squared minus the separation in space squared. And we can do the same in the red reference frame. And as it turns out, although it's not entirely evident from my diagram, this is our constant. So our space-time interval, delta S, is invariant. And that allows us to figure out, in a slightly more simple manner, given particular information, the relationship between time and space intervals in different reference frames.